Hello guys, we are back with our next lecture. In this lecture, let us go through the next topic. So in the last lecture, we discussed about a page fault and all those concepts, right? Yes. So everywhere I just left one question. So that is whom you are going to replace. So that's a question, right? Yes. So now we'll be discussing about that question, guys. So that is nothing but page replacement algorithm. So whom you are going to replace is what we are going to decide in this lecture, guys. Okay. So this particular topic has been already been covered in computer organization, guys. So anyway, I'll be repeating the problems, but I will be showing you that problem. Like one problem I'll be showing you in that book only. Okay, so if you are having any doubts in this particular lecture, you can watch that lecture also. Both of them will be the same concept only. Okay, yes. So this is a page replacement. So basically, why do we do page replacement, guys? So assume that you are searching for a particular page which is currently not available in main memory. So what you will do, you will ask a secondary memory to transfer that page to the main memory. But if a main memory is completely full, what you will do, you need to knock someone out to the main memory, into the secondary memory, and you need to take this new guy. So whom you will knock is the question, right? Whom you will send outside is the question, right? Yes. So that is given answer by this page replacement algorithms, guys. Okay. So you are going to select a victim and you are going to swap him out and you are going to swap in our required person, right? Yes. And whenever you are doing these kind of things, you are going to change the invalid bit to valid, right? Yes. And you will update that frame number and all those concepts also, right? Yes. So now let us start with the first algorithm, that is a FIFO, guys. That is a first in, first out page replacement algorithm. Okay, guys, I'm not going to bore you with theory. Let us directly jump into a question, guys. Okay, yes. So this is the question. So don't worry, I'll be solving it step by step. Okay, yes. Okay, and these are some popular questions, guys, to be clear. Every alternate years you can expect at least one question from this. Okay, yes. 2 0 3 0 4 2 3 0 3 2 1 2 0 1 7 0 1. So these are all the pages they are saying. So basically our CPU is requesting for these pages, assume in that way. Okay, yes. And assume that they will say this in the question, they will give this particular string in the question, and along with that they will say how many frames we are having. So in this question we are having 3 frames. So indirectly our page table is having 3 slots, guys. So that's what it is indirectly saying. Okay, yes. So initially there will be nothing, right? So it will be empty. So once I got a 7, what I will do, I will give one slot for 7. Okay, so I am applying FIFO, right? Yes. So first in, first out. So whoever comes in first, he will be moving out first out, right? Yes. Okay, so 7 came inside. So after that 0 wants to come. So 7, there is a space, so I will give 0 also space. So once 7 0 is done, 1 wants to come. So 7 0 1. So 1 also completed. So now 2 wants to come, but there is no space, right? So what we are applying here, FIFO. So who came first, guys? So 7 came first. So we will send him out and we will replace that 7 with 2 now. Okay, so now moving on. So we got 0, but 0 is already in the list, so there is no issue for it, right? Because 0 we will read from here only. Okay, so now moving on to 3. So 3 is not in our list, and who came after 7, guys? So 7 is done. So after that 0 came, so you are going to push that 0 also outside. So now in place of 0 you will place 3. Okay, so 3 is done. So again 0 came. Okay, so now who came after this 0, guys? 1 came, so you will knock that 1 out. Okay, so you will place that 0. So it becomes a 2 3 0. So if you observe, layer by layer we are kicking, guys. So after this guy, whom you will kick this 2, right? Yes. So this is done. So now again 4. So 4 is not in the list, so we are going to push this 2 outside and place that 4. Okay, so next time whom you will push out? 3 you will push out. So now 2 came. So it is, what will be the thing now? So now instead of, in place of 3 you will place that 2. Okay, so now 2 is done. So now 3 came, but 3 is not there in all, so you will push this guy out. So if you observe 1 2 3 1 2 3, so in that fashion it will go, guys. It's a simple method which I apply. Okay, yes. So now we need to push a 3 inside. Okay, yes. So 3 is done. So 0 is also not there in this, so we'll push that 4 outside. Okay, so now 0 is done. So now 3 is already in the list. So what about 2? 2 is also in the list. What about 1? 1 is not in the list, so we'll push this 2 outside. Okay, okay, so 3 is done, 2 is done, 1 is done. So now 2 is not in the list, so we will push this 3 outside, right? Yes. So 0 1 2. So 0 is already in the list, 1 is also already in the list. So when it comes to 7, 7 is not there in the list. So we are going to push this guy outside, right? So 7, 1, 2. Okay. So after 7, 0 is there. So 0 is not there in the list. So we will push this 0 outside. So 7, 0, 2. Okay. Similarly, 1 is also not there in the list. So we will push this last guy outside. So at the end, we ended up with a 7, 1, 0 and we pushed many people outside in the middle, right? Yes. So count how many times the page fault occurred, guys. So page fault is nothing but how many times you kicked someone or you entered for the first time. So basically here, this is one page fault, right? Yes. Similarly, this is the second page fault, third page fault, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11, 12, 13, 14, 15. So in each of these cases, we forcefully kicked at least one guy outside, right? Yes. So these are nothing but the page faults, guys. Got it? Yes. So you can draw in this way whenever you are drawing in the examination. You can solve in a simpler way. I will be showing you in PYQ page, guys, how exactly you can solve in examination really fastly. Okay. So if you draw it step by step, the approach will look in this. So first I pushed 7. So it is a fault. Then 0. Then 1. Then 2. Then for 2, as a 7 came first, I knocked him out and I pushed 2 inside. So in that way, so whoever is coming first, we are pushing him outside. So that is the concept here. FIFO. Okay. Yes. So here 0 is found already. So there is no fault here. Similarly, we continued again 3 and 2. There is no fault here because those 2 are already available. Again here 0 and 1, they are already available. So at the end, we got a 15 faults, guys. Got it? Yes. So basically indirectly 15 times you pushed from secondary memory to main memory a particular frame. Got it? Yes. So what is the concept about FIFO, guys? You are going to push the person who came first outside. Okay. Yes. So very simple to implement. Oldest page is replaced from the replacement, right? Yes. So whoever came first means the oldest guy. Okay. Similarly, performance is not always good, guys. So we cannot say, right, because it completely depends on the luck. So if you observe here carefully, so see, guys, I'll be giving you some hints here. Okay. So here where it is there, guys. So just give me a second. I think it might take some time for me to recognize, but just give me a second. Okay. So see here. So basically here we replaced 3 with 2, right? Yes. And previously we replaced 2 with 4. After that 2 was requested. Here we replaced 3 with 2. After that 3 was requested. Okay. So here we replaced 0 with 3. After that 0 was requested. So basically here, if we are careful, we can change this 4 only continuously 2 times and all these things will be safe, right? Yes. So in this way, there are various things which you can optimize and which you can reduce the faults, right? Yes. So that is the reason why here this is not the best approach, guys. And we are just blindly doing it based on who is coming first. So that's not a good idea, right? Yes. So that is the reason why FIFO is not that much used, and there is a huge disadvantage with respect to this FIFO, guys. So that is called as a Belady's anomaly, guys. So what exactly this anomaly is? So the basic thing which we assume is, so if you ask your friend, so you will ask him, so I gave 3 frames for this particular series and I got 15 faults, and you will ask your friend that if I give 4 frames, will the faults will reduce? So most of your friends, I am 100% sure, they will guaranteely say that yes, it will reduce because you are giving more slots, right? They will think in that way. But the thing is, it is not with all the cases, guys. So that is nothing but the Belady's anomaly. So for some page replacement algorithm, the page fault rate may increase as the number of allocated frames increase. Okay. So I know that most of the students will be like, we want example for this, right? Yes. So that is the reason why I took a specific example in our book. So this is an example, guys. Okay. So here they gave, so instead of cache lines, assume them as a frames, guys. So they gave 3 frame slots, guys. Okay. And they started pushing. So here we pushed 1 first. Okay, so 1, 2, 1, 2, 3. So let us try to identify, guys. Okay, so just give me a second. Okay, yes. So whom you will replace, guys? So 1 guy came first. So in place of 1, you will place 4. So 4, 2, 3 will be the answer. Okay. Similarly, 1 came now. So so now 4 has been replaced. So now you will replace this 2 and you will place 1. So 4, 1, 3. So when it comes to 2, 2 is also not available. So in place of 3, you will place that 2. Nice. So 2 is done. So now in place of 5, you will place, in place of 4, you will place the 5. Similarly, 1 is available, so no issue. 2 is available, no issue. 3 is not available. So in place of a 1, you will place that 3. Nice. Okay. Similarly, 4 is not available. In place of 2, you will place that 4. Okay, so 5 is available, so no issue. So in total 1 2 3 4 5 6 7 8 9, so 9 faults have been occurred here. Okay, so now the same question we will be solving with the 4 frames, guys. So most of us will be thinking 100% it will be less than 9, right? But if you try to solve, so 1 will take its slot, 2 will take its slot, 3 will take its slot, 4 will take its slot. So 1 is available, 2 is available, 5 is not available. So who came first? 1. So in place of 1 you will place 5. Okay, so 1 is gone. So in place of 2 you will place 1. In place of 3 you will place 2. In place of 4 you will place 3. In place of 5 you will place 4. In place of 1 you will place 5. So in that way, if you observe here we ended up with the 10 faults, guys. So with the 3 lines we got 9 faults, with the 4 lines we got 10 faults. So indirectly this is the thing, right? So this is what Belades and Amelie explains, right? Yes. So this is the issue with respect to FIFO, guys. Okay, and I am being 100% clear here, guys. So there are around, if you check the PYQ page, there are around 5 to 10 questions directly based on Belades and Amelie, guys. So that much important this term is there, guys. Okay, in true or false or various places you can find this Belades and Amelie, and they will say that whether the statement is true or false. So in that way, okay, yes. So now I hope everyone got a clear idea with respect to that, right? Yes. Okay, so I think everyone got a clear idea with respect to this FIFO, right? So first in, first out. Okay, so as the video is a bit lengthy, now I want to break the video here, guys. So in the next lecture we'll be discussing the second approach, which is called as optimal page replacement. Okay, yes. So let us meet in the next lecture and discuss optimal page replacement. Okay, yes. So let us meet in the next lecture. Thank you. Thanks for watching. Like, share and subscribe for more awesome videos like this. Thank you.